Welcome to a video on Wallace's formula to determine definite integrals involving powers of sine or cosine on the interval from 0 to pi over 2. So these formulas allow us to easily evaluate the definite integrals of powers of sine or cosine on the interval from 0 to pi over 2. And these are really quite amazing formulas. It states here that if n is greater than or equal to 3, then this definite integral is equal to 2/3 times 4/5, so on all the way out to n minus 1 over n, and the product of these fractions will give us the value of this definite integral. Notice the numerator is a sequence of even whole numbers all the way out to n minus 1, and that the denominator is a sequence of odd whole numbers all the way out to n. If n is even and greater than or equal to 2, then this definite integral is equal to 1/2 times 3/4 all the way out to n minus 1 divided by n times pi over 2. So again, if n is even, notice that the numerator now is a sequence of odd whole numbers all the way out to n minus 1, and the denominator is now a sequence of even whole numbers all the way out to n. Then we have to multiply this product by pi over 2. Now these formulas are only showing cosine to the power of n, but it's also true for sine to the power of n. While this result is quite amazing, the proof is not shown here, but would require integration by parts and proof by induction. Let's go and just take a look at a couple examples, and then we'll verify it with the graphing calculator. Okay, so the first thing we should notice here is we have the interval from 0 to pi over 2, and next we only have cosine, and it's raised to the power of 4. So we'll use Wallace's formula when n is even and greater than or equal to 2. So in this case, n is equal to 4. So this definite integral is going to equal 1/2 times 3/4. And notice that this 3 is n minus 1, so we're going to stop here. And also notice that the denominator stops at n, which is equal to 4. And then we're going to multiply this by pi over 2. So this definite integral is equal to 3 pi over 16. Let's go ahead and convert that to a decimal, and then we'll check this on the graphing calculator. So there's the decimal value of 3 pi divided by 16. And now let's go ahead and check this definite integral. If we press math option 9, our integrand was cosine to the 4th x. Comma x comma 0 comma pi over 2. And as you can see, the result is the same. And again, the decimal value was approximately 0.589. So again, to me, it is truly amazing that it's so easy to evaluate this definite integral, given that we've been practicing so many different techniques to evaluate integrals involving powers of sines and cosines. Let's go and take a look at another example. Again, this is only true on the interval from 0 to pi over 2. And now notice we have a power of sine. But remember, it's also true for sine, even though the formulas were only given in terms of cosine. So now n is equal to 7. So n is odd and greater than or equal to 3, so we'll apply this formula here. So if we take a look at these fractions, notice the numerators are going to start at 2 and go out to n minus 1, and the denominators start at 3 and go out to n. So we'll have 2/3 times 4/5 times 6/7. And now we'll stop because n is 7, so our numerator is now 6 and our denominator is now 7. So this product will equal the value of this definite integral. Looks like we'd have 48 over 15 times 7, that's 105. Let's go ahead and convert this to a decimal and then check it on the graphing calculator. So this is approximately 0.457. Let's go ahead and check this using the integration tool on this calculator. Math option 9. Our integrand is sine to the 7th x. And again, the result is the same. Okay, that's going to do it for this video. I hope you can make use of Wallace's formulas for integrating powers of sine and cosine on the interval from 0 to pi over 2.